Hello everyone. Today we are going to talk about the polyatomic ions and why it is very important for us to learn about the polyatomic compounds, because there are many products that we are using in our daily life, and these products contain polyatomic ions, which is a group of ions combined together, and they have an overall charge. So they are working together as a unit. For example, if we look to this medicine, that is contains, if I look to the label, I will see that there is aluminum hydroxide. And aluminum hydroxide is antacids used to treat acid indigestion. So it is used as the treatment. Which is calcium sulfate. And also this compound contain polyatomic ions. Also the fertilizers, this bottle is a fertilizers, and on the label we will find that it's ammonium nitrate, and also this compound contain polyatomic ions. So the learning goals for our class today is to learn about how to write the name and the formula for anionic compounds containing a polyatomic ion. But the first step, I want to know what is the meaning of the polyatomic ion. What is the polyatomic ion? The polyatomic ions, it is group of atoms with an overall charge. So this is group of atom, overall charge, and they often consist of nonmetals such as phosphorus, sulfur, carbon, or nitrogen and oxygen. So the polyatomic ions, I'm going to repeat again, are group of atoms with an overall charge, often consists of nonmetal such as phosphorus, sulfur, carbon, or nitrogen and oxygen. This table includes the names and formulas of some common polyatomic ions. And the question which will come to your mind at once, do I have to know and memorize the names and the formulas of this table? And the answer is no. During the test, we are going to provide to you a table for the polyatomic ions. But let's learn about it. We said that the polyatomic compounds must be nonmetals. So, and they have group of atoms and they have overall charge. Let's talk about if I have hydrogen. And the hydrogen, as we said before, when we were talking about the periodic table, we said that however the hydrogen atom or the hydrogen element in the periodic table is located on the left side of the periodic table within group 1A, but hydrogen is considered as an non-metal, and that the hydrogen is an exception. So if the hydrogen combined with one atom of oxygen, and they will have an overall charge 1 minus. This group as a whole, we are going to call it polyatomic ion, and we are going to name it as hydroxide. So when I hear hydroxide, I will think about it is a polyatomic ion. It has an overall charge 1 minus. It consists of two nonmetals, which is the hydrogen and oxygen. Let's have another example. When the nitrogen combined with 4 hydrogen atoms, that will make a polyatomic ions is named as ammonium. And take care that the ammonium, it has an overall charge of 1 plus. And if you take a look to the charges of the polyatomic ions in this table, you will notice that all of them are negatively charged except the ammonium. So the ammonium as a polyatomic ion is an exception because it has an overall charge of 1 plus. Nitrate, nitrogen and atoms of oxygen with overall charge -1. Nitrite, NO2 minus. Let's go to the chlorine. ClO4 1 minus. That's named is perchlorate. ClO3 1 minus, chlorate. ClO2 minus, chlorite. ClO minus, hypochlorite. So we have perchlorate, chlorate, chlorite, hypochlorite. Let's go to the carbon. Carbon, when it combines, and all of them are nonmetals. Carbon with oxygen, 3 atoms of oxygen with an overall charge 2 minus, that's carbonate. HCO3 minus, hydrogen carbonate, or sometimes we give the name of bicarbonate. So they are the same. I can say that's hydrogen carbonate, or I can say that, or can name it bicarbonate. They are the same compound. Cn minus, cyanide. C2H3O minus, acetate. Let's go to the sulfur. SO4 2 minus, sulfate. HSO4 1 minus, hydrogen sulfate or bisulfate. SO3 2 minus, sulfite. HSO3 1 minus, hydrogen sulfite or bisulfite. Phosphorus, BO4 3 minus, phosphate. HBO4 2 minus, hydrogen phosphate. H2BO4 1 minus, dihydrogen phosphate. BO3 3 minus, phosphate. Again, as I told you that for the previous table, there is no need to memorize all of them, just only we have some famous or common polyatomic ions that we are going to use it a lot and you are going to listen about them in this course. Like what? The sulfate, SO4 2 minus, phosphate, BO4 3 minus, nitrate, NO3 1 minus, ammonium, and take care that the ammonium, the charge is 1 plus, hydroxide 1 minus, CO3 2 minus, carbonate, hydrogen carbonate, HCO3 1 minus, and this is the acetate, CH3COO 1 minus. Let's go to the next step. We want to learn how to write the formula for compounds containing polyatomic ions. Actually, we are going to use the rule that we used before when we were learning about how to write the simple ionic compounds. First step, I'm going to write the metal, which is positively charged. The second step, I'm going to write the non-metal, which will be polyatomic ion. And then I'm going to balance the charge. So the charge, the overall charge on this compound must be 0. Let's have an example. Magnesium, and the magnesium is a metal, and the magnesium is found in the periodic table in group 2A. So the magnesium, check the periodic table with me. When the magnesium will make an ion, it will be Mg2 plus. This is the cation. And now it will going to react or combine with the NO3. And we said that NO3 is a polyatomic ion. And the overall charge of the nitrate is 1 minus. But we are not going to write the letter, the number 1. We are going to make minus. So think with me. Now we have 2 plus, but the nitrate is 1 minus. That means that to make or to balance the charges, we want 2 nitrate molecules. So here the total, it will be 2 minus, while here it is 2 plus. So the overall charge will be 0. So how I'm going to write the compound as a in the end, it will be magnesium. The first step is the metal. And then between brackets or parentheses, we are going to write the polyatomic ion. And then outside the brackets, I'm going to write the subscript. So it will be Mg, and between brackets, it's NO3, and the subscript will be outside here. Let's practice and let's see more examples so we are going to learn more about it. Let's have, and now we are going also to pronounce or how to name the compound that containing the polyatomic ions. This is the sodium, which is the metal, sodium in group 1A. So it will make cation 1 plus. Where the sulfate as a polyatomic, it has overall charge 2 negative. That means that to balance the charges, we want 2 atoms of sodium. So here the whole total charge, that will be 2 plus, and the sulfate will be 2 minus. So we balance that charge on the compound. So how I'm going to write it, I will start the first step. I'm going to write the metal. Then I'm going to write the subscript because we want 2 atoms of sodium cations. And then between parentheses, I'm going to write the polyatomic ion, which will be SO4. How I'm going to name this compound, I'm going to say sodium, which is the metal, and then the polyatomic ion sulfate. So it will be sodium sulfate. Let's have another example. This is the symbol of iron, and iron is located in the periodic table in the transition elements. That means that they may have more than that one charge. So the iron, maybe it will be 2 plus, and maybe it will be 3 plus. And we learned about that before. But in this compound, we are going to use the iron 3. That's iron 3. The phosphate is 3 minus. So the iron is 3 plus and the phosphate is 3 minus. So I'm going to use 1 of iron and 1 of the phosphate to react together. So it will be FePO4. But when I'm going to naming it, I have to say iron 3 because I used the transition element iron 3 plus, not 2. So I have to mention which one I used. So it will be iron 3 phosphate. Let's have another example. This is aluminum, and aluminum in group 3A. So when it makes, it's a metal, when it will make ions, it will lose electrons. So it will be cation, aluminum 3 plus. While the carbonate, as a polyatomic ion, it has 2 minus. So let's see how to balance the charges. In this case, I will need 3 carbonate and 2 aluminum. Let's see the charges to balance the charges between them. In this case, I will have 6 positive charges and I have 6 negative charges. So I will take 2 aluminum cations, so it will be Al2, so this is the subscript, while I will use 3 carbonate, so it will be CO3 between parentheses, because we said that the polyatomic ions, we are going to put them between parentheses or brackets. And then outside the parentheses, we are going to add the subscript. So that will be aluminum carbonate. So how I'm going to naming it, starting with the metal, aluminum, then the second step, I'm going to name the polyatomic. If the metal is from transition elements, so I have to write what is the charge, like it is, like as we said that iron 2 or iron 3. So between brackets, we have to mention the charges of for that transition metals. This is some examples of compounds which is famous, and as I said that we are using them in our daily life, and they contain polyatomic ions. For example, I'm not going to mention all of them, but I recommend for you to read them, because you are going to, in your daily life, to see these formulas or these compounds a lot, these polyatomic ions, so you will know that, oh, that's a polyatomic ion. For example, barium sulfate. The barium sulfate is used as a contrast medium for X-rays. Let's have the calcium sulfate, for example. It's the plaster casts. Let's have another. Let's take this one. Iron 3 phosphate, which is food additive. So all of that is compounds containing polyatomic ions. This is calcium carbonate. This is calcium phosphate. All of them is polyatomic, that's compounds, contains polyatomic ions, and they have like we use them in our daily life. Let's take a practice. Let's practice together, and let's discuss some of the study check. This study check asked me to write the formula for the ionic compounds containing ammonium ion, and I know that the ammonium ion is the polyatomic ion, okay, and it is NH4, and we said that the ammonium as a polyatomic ion, it's an exception because it has a charge, the overall charge is positive, as if it is a metal, but of course it is not a metal, it's a polyatomic ion. And the nitrate ion, which is NO3, and the overall charge is 1 minus. So we want to check for these compounds about if they have ammonium ion and nitrate ion. Let's take this. So this is ammonium nitrate, and it is the charges, this is plus, this is minus, so the charge on the compound is balanced, so that's ammonium nitrate. So this is the first one. Let's go to the second one. This is